this is Captain Chaudhari in my series of videos on marine astronomical navigation. I was doing planets and today I'm going to do a calculation in respect of Venus. Right? Venus, as you know, is an inferior planet and also a neighbor to the Earth on the inner side. Like Mars is on the outer side, Venus is on the inner side. Now the numerical is like the maximum elongation of Venus or an inferior planet is 47 degrees, and the Earth-Sun distance can be taken as 93 million miles. You are required to find out the distance between the Venus and Sun. What is the distance between Venus and Sun? What is the sidereal period of revolution of Venus, and what is synodic period of Venus? In my last video we have discussed what is sidereal period, what is synodic period, and in this question, when we do this question, it is assumed that the orbits are circular and coplanar, right? So let us say here is Sun, this is the orbit of Venus, right, and this is the orbit of Sun. Let us assume that Earth is over here. So we have seen that the elongation is the angle measured at the center of Earth between the directions of the Sun and a heavenly body. It may be moon or it may be a planet, right? But we are talking about the maximum elongation. Maximum elongation means we have done this, that Venus cannot be in opposition because it is inferior planet. Maximum you can have is inferior conjunction and superior conjunction, and therefore the elongation which the Venus can have is limited to 47 degrees, as is said in the question. The maximum elongation, that is maximum it can move away from the Sun, is 47 degrees. And while the Venus is here at the tangent drawn from the Earth, mind you, we are doing the calculations in the plane of ecliptic because elongation is the angle measured in the plane of ecliptic. Can we say that this angle is 90 degrees? So if this angle is 90 degrees and we know this distance is 93 million miles, so we should be able to find out what is this distance. So you can see the relationship opposite, this side is opposite and this side is hypotenuse, is equal to sine theta. So can we say sine 47 degrees is equal to opposite, that is Venus Sun distance, divided by hypotenuse, that is 93 million miles. So let's do this. We have sine 47 degrees equal to into 93 gives me 68.0, approximately 68.016 million miles. So this is the distance, or we can round it up to 68 million miles, right? Just to understand, make the question, not make the question unnecessarily complicated, just for no reason. So let's say that the 68 million miles is the distance between the Venus and Sun. Now once we know the distance, we'll apply Kepler's third law, and Kepler's third law says that T square upon D cube is fixed for the planets of solar system. So this means that TV square upon dV cube is equal to TE square upon DE cube, where TE is the sidereal period of Earth, so that is 365.25 whole square. DE cube, that is the distance of Earth cube, that is 93 million cube. This is equal to TV square upon dV cube, and dV is nothing but 68 million cube. So can we say that TV square is equal to 365.25 square into 68 divided by 93 cube. This is in the terms of million miles. So therefore TV should be equal to 365.25 into 68 by 93 to the power 3 upon 2. Right? So let's solve this. This gives me 0.625. This multiplied by 365.25 gives me 228.4. 228.4 days. So this is what we get, the sidereal period of revolution of Venus. Sidereal period of revolution of Venus means when Venus starts from here and there is a star, in the same line of Sun. Venus comes back to this position, and when Venus comes back in this position, Venus finds the Sun and same star in line once again. So this is completion of 360 degrees in space by Venus. That is the sidereal period, 228.4 days. We have the Venus-Sun distance as 68 million miles, and we have the sidereal period as 228.4 days. Next we have to find out the synodic period, and we have the formula 1 upon synodic period is equal to 1 upon sidereal period, difference 1 upon 365.25. So it will be 1 upon 228.4 minus 1 upon 365.25. Okay, let's do it. 1 divided by 228.4 minus 1 divided by 365.25. This gives me 609.59. This gives me 609.59 as the synodic period. So this is how we have found out the distance of the Venus initially by geometry, and once we got the distance, this distance is used to find out the sidereal period of Venus, because we have the Kepler's third law that T square upon D cube is fixed for the planets, where T is the sidereal period of the planet and D is the distance along the semi-major axis. In case of Earth, we assume that this is about 93 million miles, and we found that the sidereal period of Venus is 228.4 days and synodic period is 609.59 days. In this picture, we can observe how we start the count from the time the Venus is on inferior conjunction. As you can see that the Venus is increasing on its elongation. At inferior conjunction, the elongation is 0. It increases the elongation on the westerly side, and subsequently what happens is Venus reaches on the maximum westerly elongation. Thereafter the elongation decreases. Eventually the elongation will become 0 once again when the Venus reaches the superior conjunction, and thereafter the elongation is easterly, because if the synodic period is say X amount, half of that amount the planet is going to be on easterly elongation, and in the other half period the planet is going to be on westerly elongation. So after the superior conjunction, the story or the journey of easterly elongation starts, and this easterly elongation will first increase to reach maximum 47 degrees, and eventually the planet will come back to the original elongation, original 0 elongation of inferior conjunction.